is 9.3a, and we are using Laplace transforms to solve differential equations. So your first step is going to be to take the Laplace transform of every term. Okay, and by definition, we have that the Laplace transform of y prime, or f of t prime, equals s of f of s minus our f of 0, which we have here, so our y of 0 equals 1, and then equals the Laplace transform of t, which is just 1 over s squared, and then the Laplace transform of y, which is just f of s. So that's just another definition. It's kind of important for solving these, so make sure you're familiar with it. So now I'm just going to collect like terms and move this equation around to get it to look more like something we can use. So we have s times f s minus f of s, and then equals 1 over s squared plus 1. So I'm going to factor out an f of s here. I get s minus 1. And then I'm also going to write this as a single term by multiplying this term by s squared over s squared. So I get 1 plus s squared over s squared. Okay, now to get our f of s alone, s equals our 1 plus s squared over s squared times s minus 1. And this does not look like something we can easily compare to our table, so we're going to have to do a partial fraction decomposition. I know a lot of you probably haven't done a partial fraction decomposition in a long time, so definitely try to go over that because I'm almost positive there will be one on your exam. So when you're doing a partial fraction decomposition, first write out whatever you're trying to decompose, minus 1, and then you set it equal to something that looks like this. Okay, and I'd say one of the most important things and one of the biggest mistakes people make is when you have something squared, you have to account for the first order and the second order. Okay, if you don't do that, you're never going to get your partial fraction decomposition correct. So make sure when you have a squared term or a cubed term that you account for all of the powers there. And then here you just have s minus 1. Okay, so actually starting the partial fraction decomposition, we're going to take this denominator and we're going to multiply it all the way through. So we get s squared plus 1 equals, so when we multiply through by this denominator, we're going to get a times s minus 1, because one of the s's canceled out to a factor of 1. And we're going to do the same thing here, so we're going to get b. Your s squared is going to go away, so you get s minus 1, and then c. So your s minus 1 is going to go away, and you're going to get c s squared. Okay, now there's a couple ways you can do this. I'm going to evaluate our s term at different values in order to solve the equation for our ABC. So at s equals 1, our a goes to 0 and our b goes to 0, so we can easily solve for our c. So at s equals 1, we get 2, so 1 squared plus 1 equals a goes to 0, b goes to 0, equals c, and then times 1. So we get that our c equals 2. And similarly, at s equals 0, we can isolate our b term. So at s equals 0, we get 1 equals a goes away. So we get b times -1, because s is 0. And then our c term goes away too. So we can conclude that b equals -1. Oh, that's negative. Okay, so I'm going to try to fit our a in here. So now we can actually just use the terms that we just solved for and plug them in and solve for a. So we get s squared plus 1 equals, so we're looking for a, so we still have that. I'm going to go ahead and distribute that term. So we get a s squared minus a s, and then plus, sorry, oh, I'm sorry, this is our negative b. So we have minus s plus 1, and then plus 2s squared. So see, I'm already all the way over plus 2s squared, and that's our c power. So from this, we can subtract this 2 here, and we'll get negative s squared plus 1 equals a s squared. And then what I'm going to do is I'm going to factor an s out of here. So I'm going to get a negative s times a plus 1. Okay, so now moving this across, I'm going to get a, actually, I'm running out of room, so I'm going to combine steps and hopefully it'll make sense. So I'm going to minus s squared plus 1 equals a s squared and minus s a plus 1 plus 1. So our plus 1s don't matter, and hopefully from this, you can see that we need something that makes s squared equal -1. I mean, equal, yeah, negative s squared. And then we also need something that makes this s term go to 0. So we can conclude from here that a also equals -1. Okay, hopefully that made sense. I know it looks a little bit sloppy, but bear with me. Okay, so I'm going to resize this, and we're going to actually solve the Laplace transform aspect. Okay, that didn't work. I'm actually going to solve the Laplace transform. I'm going to make it really small so we have room. Okay, so solving for the Laplace transform, we now can rewrite this as something we can do. So we have f of s equals our a. So our a was -1, so we have -1 over s, and then minus our b was also -1. So we have 1 over s squared, and then c was our only positive term, so we have plus 2 times 1 over s minus 1. Okay, and now we can take the inverse Laplace transform of the whole thing. So the Laplace inverse of f of s equals the negative Laplace inverse of 1 over s. Oh, plus, sorry. Not equals to. Minus the Laplace transform inverse 1 over s squared, and then plus 2 times the inverse Laplace transform of 1 over s minus 1. Okay, so the Laplace transform of f of s is just going to be y of t. The Laplace transform of 1 over s is just 1, but we don't forget about this negative sign, so we get a negative 1. And then the Laplace transform inverse, the inverse Laplace transform of 1 over s squared gives you t, and don't forget about your negative sign, so we have negative 1 minus t, and then we have to deal with this, which is slightly more complicated. Not really. There is a table entry it looks pretty much just like this, so hopefully it makes good sense. Just pull out your 2 and then e to the t, and that is the whole problem, and hopefully that made good sense. Please let me know if you have any questions.